Once again, very good morning, everyone. My name is Naushad Nazir Pasha. Let's get started with the introduction to Docker. Give us a moment. So we are going to get started with introduction to Docker. So in this session, I'm going to explain you. So what is Docker? How is containerization different from virtualization? And how to containerize an application? And deep dive into containerization. Let me first introduce you what is Docker. Taking a minute. So we want to get introduced with Docker. In this session, I'm going to help you understand the various free compute services available for you as an option. How is containerization different from the virtualization? What is Docker? How container-based application works? Various Docker terminologies and additions. So when you think of running your application, you have three choices. You can have your application running on a physical server using a virtualized server or maybe a containerized server. So three different infrastructures available as an option, right? So when I say physical server or a bare metal server, nothing but the complete dedicated server available for you on which you can run your application directly. The beauty with this type of infrastructure is all that is available and that physical server is dedicatedly available to your application, and that way you can expect the highest of the performance from the server. But there are a few drawbacks as you will not be able to share the resources. I mean, we generally don't run multiple applications on the same server due to incompatibility and the other hardware challenges. We instead prefer running them on a separate server and we may not be able to share the hardware resources. So we generally run one application per one server. This way, it's going to be an expensive solution, and there are chances of mismatch of the capacity. You may not be able to make use of all of the hardware resources if there is more hardware resources than what your application might need. Or maybe your application needs more hardware resources after over a period of time, but the hardware limits how much of memory and CPU you can add into it. That may also become a challenge. So there are high chances of mismatch of the capacity. Also, maintenance of that hardware is also a challenge. I mean, you need to have a dedicated space where you keep the servers, you maintain the temperature, a lot of other maintenance involved, which is going to be an expensive. Now, nobody wants to maintain the hardware. Instead, somebody to maintain, we don't mind paying something extra and take less risks and run our applications without any challenges, which is where immediately after the bare metal infrastructure, the virtualization picked up very well. So virtualization is the technique of virtualizing the underlying hardware resources such as CPU, memory, storage, right? So on top of hardware, you can have a hypervisor running. Actually, there are two types of hypervisors, type 1 and type 2 hypervisor. So if the hypervisor runs directly on top of hardware, you call it as a type 1 hypervisor. If you have the hypervisor running on top of the host OS, you call it as a type 2 hypervisor. So mostly the training and learning environments and development environment, they prefer using the type 2 hypervisors. We talk about it in a bit. So for now, hypervisor is a piece of software that creates and manages virtual machines. Let's keep that way. And there are many options available to pick our own choice of type 1 or type 2 hypervisor. So hypervisor creates and manages the virtual machines. Each virtual machine requires the hardware resources, a CPU, memory, and storage. Once the virtual machine is created, we need to install a guest operating system on top of that. And then our application and application specific binaries and libraries. So on a same single hardware, we can run multiple virtual machines, yet they are isolated from one another, and the hypervisor takes care of that isolation. On each of the virtual machine, we're going to install the guest operating system of our choice, right? So you can have all of the virtual machines with the same operating system with a different flavor, or maybe altogether a different operating system. I mean the Windows and Linux. Completely, absolutely possible and flexible. So this way, virtualization eliminates the need for an extra hardware resources for each of the application to run. A same set of hardware can be shared between multiple applications and yet they are isolated from one another. So it is not a virtualization discussion to have in detail and depth. I just wanted you to know what is virtualization and so that when we start learning about containerization, we wanted to know how is containerization different from the virtualization. So let's have some more details, some more basic details of virtualization. As I mentioned, hypervisor is a piece of software that creates and manages virtual machines, and there are two types of hypervisors. Type 1, which runs directly on top of the hardware. Examples include KVM, Xen, Hyper-V, SXE, SXI are the examples of the Type 1 hypervisor. Whereas Type 2 hypervisor runs directly, on top of the host operating system. For example, the Oracle VirtualBox, VMware Workstation are the examples of the Type 2 hypervisor. In my case, mostly I'm going to use VMware Workstation as my hypervisor for the demonstration purposes. Just wanted you to know. So, what is the difference between type 1 and type 2 hypervisor? So, type 2 hypervisor runs on top of the host OS. I have the VMware workstation as I said. which is running on top of my Windows 10 as a host OS. So I'm working with the type 2 hypervisor. This give me a flexibility to be able to make use of the underlying host OS, also um, run multiple guest virtual machines. Pardon me. So the Type 1 hypervisor runs directly on top of the hardware. We don't need a host OS. I mean, in production, we want to get the highest of the performance from the Type 1 hypervisor. We don't need a layer between the hypervisor and the hardware. Whereas Type 2 hypervisor is going to be slow in terms of performance because there is a middle layer between the hypervisor and the hardware. So before I get into drawbacks with the virtualization, I would like you to know what is containerization and then how is containerization different from the virtualization. So containers are a method of operating system level virtualization. Just like just like virtualization needs some hardware, containerization also requires the hardware, CPU, memory, storage. So you have a hypervisor that creates and manages virtual machines. So in the containerization, we have the CRI, as in container runtime interface, which creates and manages containers. There are many different CRIs like Docker, Containerd, Cryo. Like there are many different hypervisors. So there are many different CRIs. Docker is one of the popular CRI. And the hypervisor is always kind of a type 2 virtualization, a type 2 hypervisor, because it needs the host OS to run. I mean, our containers doesn't have the guest operating system. They all rely on the underlying host operating system, which is why our CRI is always kind of a type 2 virtualization. It's just for the understanding. I'm trying to do that comparison that we cannot have the CRI run directly because all of our containers and application rely on the underlying host OS as we don't install the guest operating system inside the container. So containers are a method of operating system level virtualization because each container is going to run as a process on top of the host operating system. Containers allow you to run your application and all of its dependencies in a resource isolated processes, meaning just like virtual machines are isolated from one another, containers are also isolated from one another. But it just the major difference is each virtual machine requires the guest operating system, whereas containers doesn't need the guest operating system. What is there inside the container image then? Because we have seen the containers are created from the container images. Either we develop or build the images, we use the readily available images. What is there inside the container image? A container image may have the application specific binaries and libraries and some of the dependencies. Let's try to get into those details. Let me do a quick demonstration on how is containerization different from the virtualization. I generally pick up this example where we wanted to deploy some 10 web servers. We have many different options available for the web servers. We can have Apache Web Server, Tomcat, HTTPD, nginx, right? So if you wanted to deploy it on some 10 web servers, so we wanted to explore how much of the time and efforts does it take to deploy these 10 web servers using the virtualized infrastructure, and we'll compare them with the containerized infrastructure. So, so I'm going to demonstrate both the examples. So for the demonstration of virtualization, as you know, I have the VMware Workstation software, and this is my VMware Workstation software. Let me bring it to you. Yeah. And for the containerization demonstration, I have a Docker engine pre-installed. Let me show you. As you see, I have a Docker engine active and running. I have pre-installed it to save the time, but I'm going to teach you also how to install Docker engine if you wanted to. So first, let me explain you how you going to deploy the 10 web servers using the virtualized infrastructure. The first thing you will have to do is you'll have to download an ISO image, maybe based off CentOS, for a virtual machine to be created, right? So I'm just going to give a simple Google search, CentOS download. I hit the official site of the CentOS and I should be able to download my choice of architecture. I'm going with the x86 architecture. I'm going to click any of this link available. That's absolutely fine for me. As you see, if you wanted to download the everything of CentOS, it's going to be about 9.5 GB. And let's see how much time it's going to take. It says few hours. It depends on the download speed. I'm going to cancel that download as I have it pre-downloaded to save the time. So ISO image size is about 9.5 GB and download time depends on the internet speed. In an average, let's say 10 minutes with a good average internet connection. Once after that, we are going to create and start a VM. Let's do that. So the creating the VM procedure may vary based on the software that you are using. If you are using VMware Workstation, the steps are going to be different. If you are using Oracle VirtualBox, steps are going to be different. So in my case, I have the VMware Workstation. So I prefer going with Linux, CentOS, some name to it. The disk space, a virtual hard disk, 20 GB, which is thin provisioned. And I'm going to customize the hardware to increase the memory to at least 4 GB. I will add one more CPU core. I will browse an ISO image which I have pre-downloaded. I'm not going to change anything else. I should be okay with it. So the virtual machine is created. It's just a virtual machine that we created. We had to power it up and go through the installation procedure of the operating system. So we're trying to bring up server inside which we can have one of the web server installed and configured. By the time that screen comes, I'm going to continue with nginx as my web server. So the dialog screens will appear that will take you through the installation procedure, which might take about 15-20 minutes, where it's going to ask you the time zone, geographical location, I mean time zone, the date and time, the root password, partitioning, software package selection. It's going to ask you a lot of different questions. So I am going to kind of jump into one of these server which is pre-installed to save the time. So I'm going to power it off and I'm going to destroy this VM. And to save the time, I have a virtual machine pre-installed, which will take about 15-20 minutes to install the OS. So create and start a VM took about say 15 minutes and I wanted to install 10 such virtual machines. I may use a very nice features of virtualization like template and then clone it. I'm not going to consider that in this demonstration. So I will have to spend about a couple of hours to bring up 10 virtual machines. When each virtual machine needs some storage space, let's say about 10 GB for the operating system, into 10 virtual machines, it's going to be about 100 GB disk space. Once we have the virtual machine ready, we now have to install and configure a web server. So I'm going to use the Nginx as my web service. I'm going to jump onto the virtual machine which is pre-installed. Um, so let me make a remote connect to this server using Putty software. So I'm connected to one of the CentOS-based server. So our objective is to install and configure Nginx web service on a virtual machine to understand how much time it takes. So DNF search. DNF is a package manager which replaces the yum in CentOS. If you have Ubuntu, you'll have to work with the apt-get command. So I'm searching for the package nginx which is available. Let me see if that package is already installed as part of the operating system. It is not. I would also like to go ahead and inquire about all of the packages which are currently installed as part of my operating system. QA as in query and list all of the packages. Let me do a word count. I have about 1352 packages installed as part of my CentOS operating system because I opted to go with GUI version of the CentOS. If I had decided to go with CLI, it would have been some less than 1000 packages. If I had selected the minimal version of CentOS, it might have brought it down to 6 to 700 of packages. So it depends on the installation that you have done. So in my case, I have the GUI version of CentOS installed. So I have 1352 packages installed. Anyways, just for your information. Now I'm going to install the nginx package. Typo, pardon me. So I just wanted to install a single package nginx, but the other dependent packages also got installed. In total, 8 packages got installed. If I look at the word count again, 1352 plus 8 packages, about 1360 packages on this server. And we are going to have such 10 servers. On each server, you are going to install 8 packages for nginx. That should be fine. But on each of the virtual machine, you are going to have 1352 packages available, duplicate packages. Wow. Why are we having these 1352 packages? install repeatedly for 10 times. Let's understand how much memory, CPU, storage it's going to consume. I mean, there are so many services part of the 1352 packages that's going to run during the server run, which our application Nginx may not require as a dependency, but still we need to have them, right? So that is where the containerization comes in picture. Why don't we install 1352 packages only once and have them use as many times we want to? So 1352 packages. On top of that, we will have Docker Engine as a software installed that will make use of that 1352 packages to run as many applications you want to, as many containers you want to on top of that. I mean, there is absolutely there's a limit on how many containers you can run, how many applications you run. But of course, on the same server, we can have many containers run. Anyways, we have the Nginx as a web service package installed. Let's go ahead and systemctl enable and start Nginx service. I can now curl into localhost. Now my local server has the Nginx web service running, right? I can even open up the browser and access it. Yeah, that should be available. So let's go back to our Etherpad. So install and configure web server is done. We have invested a lot of time. If you have to summarize, how much time do you have to spend to bring up 10 web servers? We just brought only one. Definitely we'll have to spend about a couple of hours of time to ensure we have 10 Nginx web servers running as a VM. Let's explore the same using the containerization. As you had to download an ISO image for your virtual machine to be created with the OS, we need something called container image for your application to run. And we are going to pull an Nginx image. So I'm connected to Docker Engine already, and as it is a fresh Docker Engine, I don't have any images available, which I will have to pull. All I have to do is Docker image pull Nginx. Now the question is, from where is this image getting pulled? So the default registry going to be Docker Hub. That is the hub.docker.com is the default registry used by Docker. We can search for the application images there. This is the image that we are trying to pull. Though we are not telling which version because there are many versions available, the default version going to be latest. As you see, from the docker.io, which is the hub.docker.com, from the default repository, which is the library, a default image version, which is latest, gets pulled. Now I have an image available, right? So how much time does it has it taken to pull the image? It just took less than 1 minute, and the size of the image is only 142 MB. The reason it took only less than 1 minute, not because it is an image, because it is very small in size. So we pulled an image for Nginx. Image size is only about 142 MB. So the reason is just to get started with this Nginx image may have only those 8 packages. If you remember, in the virtual machine, we had to install packages for Nginx. The container image may only have these 8 packages. I mean, the Nginx image and some of the package and some of the dependencies, which is why the container image is very small in size. So the pull time. Our ISO image took about 10 minutes or more. Our container image, as it is small in size, it takes about less than a minute, right? So let's go and create and start a container, just like we created and started a virtual machine. So Docker container ls-a to just verify if we have any containers. As you see, I don't have any as it is a fresh Docker engine. So I'm going to run the command docker container run. Let's give it a name to the container. Let's call it as web server 01 hyphen dit as in detached interactive terminal and the image that I'm going to use. So I want to create a container named web hyphen server 01. There you go. The container is created and started up and running. It's just a blink of an eye. The container is ready to be used. And each container gets the IP address so that we go ahead and access it. We just have one container for now, and our application becomes accessible. And we can spin up as many containers we want from the same container image. We just have one image pulled. I'm going to create few more. As you see, each container is just taking few seconds to be up and ready. So if I now try to verify the list of containers, there are 5 containers running. And how much disk space might have they consumed? I just need to use an extra option -s for storage. As you see, only few KBs, which is for the container runtime. But also in the bracket, it says the virtual size of 142 MB, which is the size of an image. But it is been referenced by the 5 containers is what it is. But it doesn't mean that you have you have 5 duplicate images. Now it's been referenced by 5 different containers. And the disk size is same because all of the containers in the same state. The moment you get inside the container and start making the changes inside that, the disk size for each container may vary depending on the data that you store inside the container. And this is basically the ephemeral storage, which is available only for the lifecycle of the container. I mean, once I delete the container, all of the data that you have it inside the container is going to be deleted, lost, because the ephemeral storage will also be deleted. Is that possible to persist the data beyond the lifecycle of the container and we don't want to lose the application data is doable. Let's see how that is done later. So to summarize, we have now created and started a container. Then we don't have to do anything extra for the application to be accessible. So how much storage space? 142 MB, which is the size of the container image, and each container needs a few KBs for its runtime. Wow. Now, how much time maybe that we have to spend to bring up this 10 Nginx web servers? Maybe just a couple of minutes. We should be ready with 10 web servers running as containers. As you now have witnessed, how quickly and easily we can bring up our applications using the containerized infrastructure. So I'm sure you are more interested to learn and understand what are the other details to know about the containerization. But I want you to know this, right? The only difference right now we have witnessed between the containerized infrastructure and the virtualized infrastructure is, or I should say containerization versus virtualization is, containers doesn't need the guest operating system. That is making a huge difference. You're not spending time in downloading the ISO image. You're not losing the bandwidth. Yeah, and you're not investing the time in downloading the such a large ISO image. Maybe you can plan to download the minimal version of CentOS. That's a different story. Yeah, so you don't have to install the guest operating system for each of the virtual machine, which takes about 10-15 minutes. It's not about one time, the time that it takes. Every time the server runs, it needs to run a lot of services which we might not be using it for our application. Every time we reboot the server, those services to be started and they continue to consume the resources from the server is the problem that we have. So we want it to be only able to run our application and some of its dependency and nothing else. We want it to be able to create and start containers as quickly as possible. Let's get back to our original discussion. So containers are lightweight. I'm sure you agree with that because containers doesn't need the guest operating system to be installed. Instead, they all can consume the underlying host operating system. Containers are faster than the virtual machine. Yes, indeed. The reason is creating the containers are quick. Starting the containers is going to be also quick. So indeed, the containers are much faster than the virtual machines. So going back to the drawbacks of the virtualization, each virtual machine requires the guest OS. It will have a dedicated kernel, its own binaries and libraries. So virtual machines requires more hardware resources. Virtual machines incur a lot of overhead beyond, what is being consumed by our application. Each virtual machine requires the guest OS, so there's a licensing cost involved. You have to take care of patching, upgrading, security, hardening of the server. You need a lot of people to work and takes a lot of time to be created and started. These are some of the drawbacks which we have identified with the virtualization. That's why we have to make a decision to go with containerization. Almost anything that we can containerize. Not everything can be containerized and not also understand containerization is not a solution for everything. So we have to also understand what needs to be containerized, what can be containerized, what are the challenges going to be during the containerization journey is also a very important aspect. Just like every virtual machine gets the IP address and a host name, containers also gets the IP and the host name. Just like every virtual machine, we can allocate the amount of CPU, memory, and storage. You can do that for your container as well. But otherwise, by default, containers consume the required amount of memory, CPU, and the storage from the underlying host OS as needed. But we can set a limit as well, which I'm going to demonstrate. So recommended host operating system where the Docker engine going to run is Linux as the Docker is developed using the Linux kernel features. The latest version of Windows Server 2019 and the higher version supports running Docker natively as well. But otherwise, a recommended host OS to run the Docker engine is a Linux operating system. Anything, I mean, any flavor like Ubuntu or CentOS, that's your decision. So just to conclude how containerization is different from the virtualization, both hypervisor or virtualization and containerization requires the hardware. In virtualization, we have two types of hypervisors. Type 1, which runs directly and get you the highest of the performance. Type 2, which runs on top of the host OS. You might have to compromise a bit on the performance. Whereas CRI, which is Container Runtime Interface, is always installed on top of the host OS. The reason is containers doesn't have the guest OS, they all rely on the host OS, so you cannot think of skipping the host OS is the idea. Can I run Windows based application on a Linux host OS? Can I run Linux-based application containers on a Windows host OS? No. Remember that because our application containers rely on the underlying host OS. So you cannot run both Windows and Linux-based application containers on the same host OS. You may have to plan to have separate Docker engine for Windows-based application, which is running on Windows, a separate Docker engine running on Linux for running the Linux-based operating system. So each virtual machine requires the the virtual hardware, the guest operating system, the application specific binaries and libraries. Whereas containers requires only the application specific binaries and libraries. It doesn't need the guest operating system. Yet, just like virtual machines, containers are also isolated. And who takes care of isolation? So the whichever the CRI that you install, for example, Docker, makes use of the host kernel features, that is kernel namespaces as a feature. Let's try to conclude. So virtualization is a method of hardware level virtualization, whereas containerization is a method of OS level virtualization. I mean, each virtual machine can see the underlying host or hardware resources, whereas containers they don't get to see the underlying hardware directly. They just consume it from the OS. In fact, this gives the benefit in containerization. I mean, if it is virtualized application, if you have to migrate from one infrastructure to another, you have to ensure the both infrastructure, I mean environments are identical. If you're trying to migrate the applications which are running on a Intel-based processor to another server which is with the AMD-based processor may be sometimes challenging because different processors offer different features. It might not be compatible. That's not true with the containerization because containers never get to see the hardware. They just consume from the OS. All you have to do is take care of the OS dependency. I mean, which is where you should not be planning to run Windows-based applications on Linux OS and Linux-based application on Windows and cross. So you just have to take care of the OS dependency and application dependency when it comes to containerization. You don't have to worry about the hardware dependency. Today you may be running your application on your laptop. Tomorrow you can run the same application which you have developed on the cloud or a bare metal infrastructure. So each virtual machine requires the guest OS, which means it will have its own kernel, it will have its own set of binaries and libraries, takes a lot of time to be created and started, and consumes more resources. Whereas containers rely on the host OS, which means they all share the underlying host kernel. They don't need the guest OS, so they don't take much time to be created and started and consume less hardware resources. So this is some of the details that you should know to understand how is containerization different from the virtualization.